So hey, Thursday afternoon, right? I hope you had a good conference so far. I hope you're going to enjoy my little talk on linking Backstage and GitHub Copilot. That is the right talk. It is in this room. I'm expecting some people to come over from room 4 because there was a bit of confusion. So some people might pop in later. And if you are here for a different talk, that's the one that you're going to hear now, unless you leave, of course. The work I'm going to present to you is some work I've done in a very small team earlier in this year. It is AI related, so I have to be more precise with the timing. It happened from about mid-March to about mid-June. That will become relevant at a later stage. It was work for a large multinational company. Unfortunately, because it is a large multinational company, I cannot name their name. The technologists were all very eager to get the story out, but the legal department said, I can only talk in broad terms. I will show you some code, but it's general code that we used from the actual project. But as I said, I can't name them. In many cases, I guess Copilot is associated with writing code, with engineering, with software engineering. Sometimes today we talk about even forward engineering to differentiate it from reverse engineering. GenAI solutions are also quite good at understanding legacy code, code that you wrote maybe a year ago, millions of lines of COBOL code from ages ago. Today, I'm using Copilot, or we are in that project. It was a proof of concept, to be honest with you. We're using Copilot in a very different way. We're dealing with different information, not with code. Maybe before I show what kind of information we're dealing with, can I have a show of hands of who of you knows Backstage? Okay, good job, I put the screenshots in. So, Backstage is a developer experience portal. It's open source software made available by Spotify. I would say it's a sensible default if you want a developer experience portal, if you want a catalog of all the components, of APIs, of services that you have. It's a really good starting point. It's not the only product in that space, but it's open source software. It's relatively easy to run and install, and it's a good choice to have. As I mentioned, I needed to anonymize it, so what you're seeing here, those components, are the demo instance that Spotify provides. And for all those components you can see listed here, they're individual pages. And you can see here, that's one of the components we're showing. And one thing that is particularly interesting today is that one here. You can have tech docs, technical documentation, attached to the components. When you configure Backstage, it's relatively easy. You can just put a descriptor into the component one. And at that client in particular, they had a super nice setup where you could store the tech docs in the same repository as the source code. And then there was a separate pipeline that was actually pushing the documents, generating the documents and pushing them into Backstage. And all of this information here is stored in GCP buckets. And that becomes important later on as well. If you look at it, this is again the example from Spotify. You can see on the left-hand side in the navigation, there's actually a little hierarchy, so it's not a one-to-one mapping. You have multiple documents per component, per service. These here look extremely short. To be honest, the ones that we found at that client were also not that long. They were usually just a handful of screens, a couple of screens full. So they were not really long novels or big tomes of information, not 100-page PDFs, just a couple of screens in most cases. And when we started the work, there were about 4,000 documents with a tendency to grow quite rapidly. So there was already a large amount of information. As I said, it was a large multinational organization. So there was a lot of information, valuable information stored in that Backstage instance. It's a nice setup, but you should always ask your question, how can you make something nice even better? So we thought, how can we make the developer experience of using Backstage even better? And one thing, I still write code myself. One thing I know is context switching is not that great. Oftentimes we, as developers, we always try to stay on the keyboard. We don't really like going over to the mouse. Backstage, of course, meant you had to switch out of the IDE. You had to go to a web browser, find the bookmark, click on it, go to the search field. It was just, I know it sounds a bit weird to complain about 3 seconds of work, but it was context switching that was avoidable. So we thought, why don't we meet the developers where they are? And where are they? Where the developers spend the most time in the integrated development environment, also, of course, Copilot is also in the IDE today. So we thought, can we somehow get those together? Can we get the valuable information that is in Backstage, make it visible inside GitHub Copilot? We chose a technology called Copilot extensions. We wanted to extend Copilot, pretty natural choice. And these extensions are accessible from Copilot anywhere. So if you go to github.com and use the Copilot there, the extension is available too. Most of the time we talk about IDEs. I'm going to show you a screenshot of Visual Studio Code here. It would work in the same way in the JetBrains IDEs. And what you can see here already are a couple of important points. We can see at the bottom, you can see this @RBC POC. That's the name of the extension. So it's really agent. I know it's so overloaded, it doesn't really mean anything anymore, but the extension has a name and you can address it directly. I can say @RBCPOC and then ask a question. It is not a tool in the MCP sense where you're making a tool available and the LLM decides to make a tool call. This is the developer being in control saying, I want to talk to that agent. I know I have a question that the Backstage portal will have the information from. Everything that is past that agent is sent to the extension. It is simply sent there. So even if I've selected, I don't know whether you can see it here, it says Claude Sonnet 3.7, it doesn't matter. The normal LLM that sits behind Copilot is not used at all. All the context is actually being sent there. These extensions are implemented as GitHub apps. It's a mature technology, has been around for ages, and is used for all sorts of other things, and Microsoft just decided to use that as a foundation for Copilot extensions. They're deployed as a normal web server, so you really have a server that you run somewhere that has an HTTP endpoint that is being called. I'll show you the architecture in a moment. And one of the very nice things was authentication is built right into the solution, proper, solid, sophisticated authentication. Because the extension request gets a token, and I don't mean a token in the GenAI sense, I mean a security token, like a bearer token, an authentication token. But then you might wonder, but there's this other thing, right? Why Copilot extension? This is MCP thing. But think back, I mean, this is mid-March. I mean, I worked at ThoughtWorks at the time, was one of the authors of the Technology Radar. We were quite aware of it. Actually, in late February, we wrote that edition of the Tech Radar, and we mentioned MCP there. But if you see the highlighted section there, you see, we said, yeah, you can run them on the developer machine, or you can run them on the server, but we haven't really seen anybody run MCP servers on a server. We normally see them locally. It's really brand new technology. And again, we're working for a large multinational company. Actually, I didn't mention that so far, in an environment where data is quite sensitive, where there's a lot of secrets, etc., information that must be protected at all costs. The whole mentality was already like, we need to be careful with this. And then, of course, you got articles like this. This was one of the original ones, where they took the IoT one and recoined it for MCP. So the S in MCP stands for security. There's absolutely zero security in MCP. There were more fundamental critiques of MCP from that direction, and there were loads and loads of articles saying there's a whole lot of problems with MCP. So what we did is we went back and said, okay, let's use GitHub apps, very solid, very mature technology. You can see I'm on a tab here that even talks about permissions, and you can see at the bottom here, the Copilot chat has read-only access, so that was really playing to what the enterprise was after, and it felt quite good. But then something happened. I don't know, nobody talked about Copilot extension. Everybody talked about MCP. A little later, that happened. Simon Willison wrote this article. It's actually a fantastic article. If you do anything with MCP or similar technologies, you should absolutely read it from a security perspective. What happened after this article? More MCP, obviously. And I mean, in the end, it's a bit ironic. I mean, Copilot extensions were considered tricky, because you had to deal with permissions. It wasn't, oh, they have permissions. Oh, no, you have to deal with permissions. You need deployments on a server. And in many organizations, it's still not trivial to get a server, like a virtual machine, installed anywhere. You also had to think about, how do I get the access tokens onto the server that normally live on my laptop? So lots of things to think about. In MCP, you could just like throw security out the window and just do it on your machine. So it just was luring people in quite a bit. And so ironically, Microsoft got the timing wrong. Today, everybody's thinking about how to make MCP secure. Microsoft thought to make it secure, the Copilot extension from the start, but that really dampened the adoption. So Microsoft was watching this. They saw how things were going. I submitted a talk to present the solution here. The talk got accepted. And then at some point, Microsoft did this. So they are sunsetting GitHub app-based Copilot extension. And I'm not sure. You definitely can't read this here. Somewhere down here in the bottom where it's so bright, it says, we've deprecated GitHub Copilot extensions in favor of MCP servers. And again, they leave it very open. An MCP server is a piece of software that can run on the developer workstations, or it's a server software that runs on a server somewhere in the cloud. They're just saying, we give up, MCP has won, GitHub apps, of course, continue to exist, but we're no longer supporting this. And the actual sunset date is it's the 6th. In 4 or 5 days, you can't even, if you just were rushing out now, you couldn't even create a new one. That capability has been turned off a couple of months ago. So here I was, right? I read this, and I was like, this is what is in the program. That's what probably got you to come to this talk. And I was like, yeah. Writing and deploying GitHub Copilot extensions, technology that doesn't exist anymore. 3 months after we did a proof of concept, together with Microsoft actually, also in the mix. But I do think a lot of the lessons learned do translate very well to MCP. And one thing else we've seen is there's a move towards server-side, because you don't necessarily want developers to always have to install all the things on their workstations if you can provide it for an entire development department of thousands of developers in a centralized place. But also, even though MCP has been super successful, there's other protocols appearing now. There's the agents-to-agents protocol, there's an agent commerce protocol appearing. So I think a lot of the lessons of how you would do that still apply. So I'm showing you a little bit still about how to deploy such an application. To start, who of you knows exactly what retrieval augmented generation is? Okay. This might be slightly boring, maybe some misconceptions, or you correct me later if you have a different understanding. At the bottom, what I'm showing here is the standard interactions almost anybody has with a large language model. You're sending a prompt, and the model sends back a response. It generates. That's why it's called Gen AI, right? It can only generate. The model has no memory. The model doesn't learn. The model has been trained. It is deployed. The weights are fixed, and it's just doing inference. And now you might say, but Erik, there is memory. If I do a chat, I can refer back and it understands the context of the conversation I have, but that actually is a little trick that is built into all the interfaces. They're just basically taking your previous prompt, its own previous answer, and the new prompt, and concatenate them together, and then send them with the next request. So this normal loop is really sending some data to the LLM generates a response. In an enterprise, of course, you have this. You have tons of documents that you actually want to query. In our case, the 4,000 plus documents in Backstage. How do you get them to the LLM? I guess a few years ago, people thought, oh, we just train our own model based on our own data. That was a bit of a cul-de-sac. That was not a thing that anybody would do. Today, of course, we all realize how impossible it would be to train our own foundational model. So there's multiple different patterns. There's model post-training, but the standard pattern that most people are using is RAG, retrieval augmented generation, to take the capabilities, the language comprehension of a large language model, and combine that with information that is not in the large language model. And arguably, in cases like this data should not be in a large language model because it is proprietary information of the company. So what you do is, we already saw the little trick here, where you are adding a bit more information to the prompt, and that's exactly what's happening. We add a retrieval component. It's a little black box that I'm going to open up for you in a moment. And that takes a few of the documents and adds it to the prompt. It augments the prompt, and now we have more information that is being sent to the LLM, and it does the thing it does. It generates the response. You can't, obviously, even with the super large input context windows of 1 million tokens, it would be a foolish idea to put all documents in there or try to put too many in there. There are effects that are still, as far as I'm aware, not fully understood, like the lost in the middle phenomenon, where documents text that is somewhere in the middle of the prompt is not as present in the LLM when it tries to answer something. It's a bit like human beings. We often don't remember exactly what happened in the middle of a novel. We understand the beginning and the end, and something similar seems to be happening there. There's also other reasons. It's, of course, super expensive to add all these tokens, etc. So there needs to be some smarts in that retrieval component. The default case was people use so-called embeddings. Embeddings are a vector representation of a text, and if the two vectors in multidimensional space point in a similar direction, then the documents are similar. If they point in separate directions, they're not similar, and the embeddings create a vector for each one of them and calculate how near they are. And that's how we retrieve them. But there's nothing in RAG that says you must use a vector database, and I'll come back to that later, actually. So, architecture. Let's talk about the architecture. So, We have the developer workstation, the developer laptop in this case. You have an open ask session, like an ask session in in Copilot in Visual Studio, and you're starting to say, add my agent and ask a question. That is first sent to Microsoft servers, to the GitHub servers themselves. They then do a lookup and say, oh, my agent belongs to this GitHub app, and then they forward the request to the web application that you have deployed. We actually happen to deploy this on GCP. We didn't even go to Azure for many different reasons that I'm not going to explain now. What our application first did was authentication and authorization. Authentication was super easy. I think I mentioned before that the GitHub servers already sent you a token. You can look at the token and you can verify it back to the server and say, give me the username for that token. And you get the username. If somebody finds the endpoint and tries to create fake tokens, the fake tokens would of course be detected. So you know you have a valid token and you have the username that you can trust. What was super nice in the case of this organization is they used enterprise managed users. It's a feature of github.com, not the on-premise one, but the cloud one, where you can manage the users yourself. And what happens is that all the usernames, the GitHub usernames, have underscore and then the name of the organization. So our authorization was super simple. We were getting the token. We were going back and going to GitHub and say, give me the username. And then we're just doing a string match on the organization. If it was there, we let the request pass through. If it was the wrong organization, we just rejected the request. There was no further authorization. Same thing on the Backstage instance. Every developer could read every document, so we're just mirroring that, but could be, with little lines of code, be relatively sure that we had a secure implementation. More interesting, though, is the actual RAG implementation pattern. First thing you need to do is you get the prompt. You need to calculate the embeddings. And we use the standard Gemini model for that. This is not an LLM. These are different kinds of models. They're also transformer models, but different kinds of models. So we use the model to calculate the embeddings. Then we look up the documents matching those embeddings. Many people use a vector database. We use the PG Vector Postgres extension for that. For the size of corpus we had, it was totally fine. And I guess for most of the cases, it's totally fine. Before you need a horizontally scalable vector database, you're probably getting into territory that very, very few organizations would get to. So Postgres Vector worked really super well for us. And we didn't store the actual documents in the vector database. There were good reasons for it. I'm going to explain them. There were also downsides that bit us later by not storing the documents. So what we did next is we then retrieved the documents from the GCP bucket. The vector database only told us the URL, the path on the bucket. Then we augmented the prompt. I'll show you in a minute how that worked. And then we just sent the whole thing to a large language model. At first, we actually used the one that you get for free with Copilot. That wasn't the best model for textual documents, so we later switched from that OpenAI-based model to one of the Gemini models. And it was really relatively simple to switch because the APIs that those models have are more or less the same. There's some lessons learned, but I'm not going to go into that. Ask me later. So, prompt augmentation, the minimum viable product. So this is what we put in the prompt. We literally put this in. We said, when answering the question, look at the files included below. We said, only use the contents from the files to answer the question. If the question can't be answered based on the files, just say so. Don't make up stuff. And we actually, for good measure, put in don't hallucinate. I don't know, that was more a plea than anything else. But it kind of worked. So this was the kind of preamble, and then this is a templating file, actually. And then we iterated over the files we retrieved. You can see this there for file in files. And we just put the text in there, location of the file, file.source URL, that's the URL on Backstage, and then the file contents as markdown. And then we just include them in these lines. That's also helpful to the LLM, as is known now, to put some graphical markers in there. And then because we were super, super lazy, we just also put that at the end. We said, at the bottom, include a list of the file locations. This saved, 5 minutes of programming time? Because, of course, you could have used the same templating loop to actually create a manually crafted list of files. But we're like, let the LLM do the work. Why should we? So now you would think, how do we get all the information? How do I get the markdown files? Where do the files come from? And so on. How do you interact? And you think I'm switching to the IDE. I don't even have to do this. The code, you'll see that in a minute, is so simple, I can actually squeeze it, with one exception, on this slide. The first bit is calculating the embeddings, and that's more or less the whole code. GenAI is a client library from Google, and I'm saying, make a connection using the Gemini API key, and then I'm saying, client, embed content, use that model. You can see it here, one of the standard embeddings models, embedding 004, and then you see contents equals message. Message is exactly the message that is coming from the user. The result is the embedding. The embedding is, as I said, a highly dimensional vector. They were between 700 and 3,000 dimensions, depending on which embedding model we used. Some of the APIs, I've done software for a long time. I'm not a data scientist. I was really surprised about some of the APIs. You think like you're asking for embeddings, which is a vector, and then you get result.embeddings, which is an array. You think that's where the vector is. It's not. It's an array of structures. And the first element happens to have the structure that has a values component, and that is the array that contains all those decimals that make up that 700-dimensional vector. Next step, we need to get the documents from the database from Postgres. We have a simple select statement here. You can see select path, which is the bucket path, the source URL from Backstage, from the docs table, and we say order this by the embeddings. And you can see there the %s where it's inserting the embeddings that we retrieved, the same array of decimals. And then we use a slightly funny operand, this less than equals greater. That is the cosine distance. There's multiple ways of calculating the distance between two vectors. You have to ask a data scientist or search the internet to find out which one to use. Cosine is the one to go with. Our friendly data scientist told us. So we're sorting it, and then we're just cutting off, and we're saying, give us the top 4. That's often called k, the variable k, the top 4 elements here. It's hard-coded. It's a Python application. You can deploy it in 3 minutes. Why put it in a configuration file? We're going to experiment with that later anyway, so we can fetch the vectors from the database. I'm not going to show you how to read a file content from a GCP bucket. That's really boring. That's what I didn't put on the slide. But the last thing, remember I said, we're going to be it markdown files, but it could be PDF on there. It could be HTML. The HTML files actually have a lot of decoration, all the navigation and so on. And there's a simple library called Markdown. That is, it's super versatile, and that's the API, right? I mean, we're instantiating Markdown, and we're saying convert the file contents. We're converting them back to bytes from UTF-8, and then say, give me Markdown. And it does, in almost all cases, the right thing. If you give it a PDF document, if you give it an HTML with navigation, it strips the navigation, etc. It is actually quite a large library. It is very versatile. It required us to change the Linux distribution of our Docker containers because we used Alpine Linux, and that had some other library conflict with what Markdown needed to interact with local GPUs. We didn't want any of that. But in the end, because the library is so versatile, it had all these demands, and we just gave in and said, whatever. I can't remember what distribution we used. We didn't use Alpine anymore. But that really is the entire code that we needed for, all the important lines of the code that we needed for the RAG solution. Now, though, this is the tech stack, Google Cloud Run, Python, Fast API. There's nothing special. It's all just standard stuff. Coming back to the architecture, how did the data get into the Postgres database in the first place? How do we have that Postgres table with all the embeddings? And that is something that in those language terms is often called ingestion, where you're taking all the data in. It's often called ingestion pipeline as well. For the first steps, we actually used our developer laptops, and we just did something simple. We just used gsutil, which you can run on your laptop, and we listed all the files in a bucket. We wrote that into a text file, one file name per line, and then we had a tiny little Python utility that was taking them and making a post request per URL to our Copilot extension. So we put the code to ingest the data into the same application because the code is very, very similar. It needs to do very similar things. But also this architecture helped us. In the end, of course, we didn't, when a document would change in Backstage or when new documents would appear, we didn't want to run an entire pipeline. But the good news was all the documents are stored in buckets on GCP, and you can attach a trigger. So what we can do, we can actually take a little trigger on the drive and say, if a document changes or is updated, make the same post request. So we had already the API in place, and we could test the same API that we would use in production later. As I mentioned, the actual steps then are very similar. You need some authentication authorization. We simply hard-coded the bearer token. It was an endpoint available in the internet, so we just wanted to make sure that not anybody who suddenly discovered this endpoint could tell us to ingest some documents. And otherwise, it is just reading the file from the bucket, calculate the embeddings, and convert it to Markdown, calculate the embeddings, and then insert or update the Postgres table with the new embeddings for the document. As simple as that. We did think a little bit about why don't we actually download the files locally and then in the ingestion push the entire file content. We didn't do that for data volume reasons on the one hand, because we didn't want to have to transmit all that data back and forth. Now you can see the data is actually transmitted between the application running in GCP and the GCP bucket that is also there. So the bandwidth is much higher, so it goes faster. But there were also concerns about having all these documents always on the developer workstation and so on. So we said, we'll just do it this way, and it should work fine. And remember, we could still have taken a copy of the document and stored it in the Postgres database. Right. There's a third part to this, local development. Sometimes, even though the cycle is relatively fast, this Python application, it's just like a minute or so until you have deployed it in Google Cloud Run, it works for you. Sometimes you want local development. You want the software to run on your laptop, you want the files on your laptop, the Postgres database on your laptop. The embedding model, there's no hope you can host that on your laptop, a sensible one, and also the LLM, we wanted to use the proper large LLMs, which you also can't host, so they stayed in the cloud. But the problem is, the request goes to Microsoft servers at GitHub and not to our laptop, right? Even if it's on the same machine, if I'm saying at my agent, it first goes to Microsoft. So you somehow need to get back from an internet address back to your local laptop. We could have used ngrok, that's also the technology that Microsoft recommends. The client happened to use Gitpod. Things move fast, by the way. It's not called Gitpod anymore. It's called ONA, which are Visual Studio instances hosted in the cloud. We didn't use them at all. We only used them as a reverse SSH tunnel. So we had Gitpod instances running with a reverse SSH tunnel. So Microsoft servers could call the SSH endpoint, which would go to our laptop. And then we could just use the same technology we would and run the Python application locally for testing, debugging purposes, for all sorts of things. Be very, very careful. This is a good pattern to have, but very careful at that point, when you have that SSH tunnel, your laptop is available on a port on the open internet, and there's lots of speculative browsing, hacking attempts, and so on. So be a little bit careful with what you're doing and know what you're doing there. So that's basic RAG. I was in a different conference in a presentation a few weeks ago, and Stuart and Garth from Liberty Mutual, an English bank, had a presentation, and maybe somebody else used it before, but they talked about the complexity berg of RAG. Sorry, another iceberg metaphor. But I mean, there's the thing you see on the surface, the embeddings we talked about, the query. But there's all sorts of things below the surface that we haven't really talked about. Prompt engineering, rewriting, query expansion, reranking, and so on and so on. I put a little asterisk on guardrails because I'm not going to talk about guardrails at all today. Mostly because this is a B2B solution that is used internally, so the guardrails are not as important, I would argue. And that's good if you want to take pictures, but you can also get the slides later. So, if you look at this architecture, the key thing here is, of course, that blue square with that little black box, the retrieval component. And I showed you the code. I showed you the simplest possible version of retrieval augmented generation. Let's dive a little bit deeper into what you would actually do in a real system when you're not only seeing the tip of the iceberg, but when you're going further down. To do that, though, I need to change language a little bit. That first step here, the retrieval, is often called semantic search. And it's called semantic search because it's not only text-based. The idea is that it understands the semantics of what you're searching for. For example, if somebody uses this extension and says, how do I install an application? If there's a document that says applications are deployed in such a way, it's a different word. But semantically, in that context, they usually mean roughly the same thing. So what we mean here is we want to do search that takes the semantics of the context into account. And speaking of context, the general word today used is that is the context. It's often called the input context window also, but you have the prompt itself and then the context, and that's context engineering. That is the whole big differentiating factor also when you look at the IDEs, when you look at Cursor versus Windsurf. How do they build the context that they send to the LLM based on where you are, what state your IDE is in? So building up the right context enables the LLM that is totally trained, it doesn't learn, it doesn't do anything anymore. Building the right context can make a huge difference in the quality of the answer the LLM can generate. So that's the context generation, context engineering here. But let's go a little bit deeper. You can see I left a good bit of space in here. So we have the user sending the prompt, and in the end we have the prompt and the augmented, the documents that are added that are being sent to the LLM. The first thing that you can do is keyword extraction. So you're taking the user prompt, sometimes they're a little bit longer, and you're sending them to a different model and say, what are the keywords? Certain parts of the prompt are more important than others. I mean, everything in the English language is important. I mean, a definite article means something different than an indefinite article, but certain parts are more important, like certain keywords like text stack or mention of Node.js or something like that. These are keywords. And we have a long history of keyword search. I mean, there's really good products. Some of them, I think the vendors are also here. There's really a whole amount of keyword search technology out there, and why not use that when the trick lies in getting the best possible augmentations for your prompt? Use keyword search. So you can extract keywords from the prompt. The next thing you can then do is you can do a weighted search. So here what we're doing is we're saying 70%, 0.7, 70% is the prompt, and 30% are the keywords. And again, there's technology that can actually do the weighting correctly, and then we're getting back 20 entries, not the 5 or the 4 we want, we're getting back 20. We're getting more than we actually wanted, because in the next step, we're doing something that is known as reranking. That's a whole different field. There's probably specialized talks about this topic at conferences of how to do that. But the idea really is you're taking the 20 documents you got back from the initial hybrid search, and now you're applying different technologies, and that can use language models, but it can also be algorithmic, or it can be a combination of both. It can be an algorithm combined with some language models to then say, of those 20 that the initial search gave us, we only select 5. Now you're like, why is it called re-ranking and not filtering? The idea was also that the order makes sense, and you kind of re-rank in which order the documents appear. Or actually, initially, it was probably meant you have the 20 documents and you re-rank them, and then you cut off the top, and then you have basically filtered it down. Some of the language is a bit weird in that space. You just have to live with it. One thing I haven't mentioned at all so far is chunking. Most of the time, the documents are larger. And if they are more than 1,000 words, you don't want to put like a 100,000 word document into the prompt. You chunk documents before into roughly 1,000 word chunks, and then you don't take the entire document, but you take the relevant chunks out. That's why you also sometimes need more than the documents. We didn't need to do that because our documents were roughly the right size already. And then I needed to squeeze in one more. That's also what is really an important technique here, is query expansion. And that goes a little bit into the semantic search. So again, if the user asked, how do we deploy Node applications at my company, you would send that prompt to an LLM and say, rewrite this in 5 different ways. And the LLM has enough information, because it's not company specific, to rewrite this and say, okay, I'm replacing deploy with install and so on. You're relying on the creativity with a higher temperature setting of the LLM to actually write the same question in 5 different ways, so that then the following search techniques can actually use the additional information to find more and more relevant documents. But in the end, you're still sending the whole thing to the LLM. Now, how do you know, with all these things that I showed you here, with all these things, when is it getting better? Is it 30%? Should we put 40% in there? 5 documents, 20 documents, all of that? And I mean, somebody said in our team, you can't just vibe check that. You can't just say, oh, that looks a bit better than the other one. You're trying to do something that is somewhat more objective. I'll come back to the objectivity of this, but evals, I guess, is a term you've all heard, and I sometimes feel we're being brainwashed to prioritize evals above else, even above experience. Sometimes you're saying, well, if the eval says it's good, it must be good, even if it goes against the expert wisdom. So be a little bit careful here, but at least you want something in a pipeline. Before we talk about evals, though, let's talk about observability. We did this from the very beginning. We logged all the interactions with the system. You can see here's an example, the prompt, tell me about the Python community. We get the list of documents back. Again, not the content of the documents, just the URLs. Get the documents back, and then the response that the LLM gave at the time. The problem, of course, was this was in the log file. If somebody later deleted the document, we could never do an eval again because we didn't have the content of the document anymore. But it saved some space in the logging system as well on this. So for evals, we used ragas. You can see the name somewhere up there, ragas.io. It's a standard library. There's other ones. This is kind of the default. Our data scientist said that's the one you should start with. And it has a lot of different metrics. And you can see on the right-hand side, the table of contents. It has RAG metrics, even retrieval augmented generation metrics. It even has NVIDIA metrics, all sorts of things that you can do when you're building such solutions. The first one, our friendly data scientist told us, is context precision. Find out how precise your context is. And this uses another LLM to say, based on the documents you're giving here, how well are the documents chosen to actually allow an LLM to answer the question? So have you kind of chosen the right documents to even allow to answer the question? And certain questions can't be answered. If you send a question like, how many components are implemented in Java, that will not work with a solution like this, right? Because if you're just picking 5 documents, unless you have a statistics document, it won't work because it can't count documents in here. You also see, I mean, for me at least, I mean, I did some math in uni a long time ago. You're immediately in data science land, and that kind of gives me an appreciation again, what it feels like for people who don't program, what it feels like when they see program code. That's not immediately obvious. The good news is, if you have a data science friend, trust them, trust the library, you only have to implement it, and the code is relatively trivial. We're using here the context precision without reference. Come back to that in a moment. And that's the entire code you need. So in the end, you're basically getting a single truth one, and you have to pass in the prompt, the documents, and the response. And guess what? That's exactly what we logged in the log file. So we can just have a simple eval script that takes the lines from the log file and then makes the calls down here. And you can see it's actually doing an LLM context precision without reference, using an evaluator LLM, and then you get a number back. 0 means really terrible, and 99 means super good. So you're like, okay, there's something missing here. Where do you get the evaluator from? Because that seems to be the heart of it. And it's super simple. We're using Gemini Flash. LangChain wrapper around Gemini Flash, and that is what is used by Ragas, and now it can do the evaluations. This is the without reference. We're only giving the prompt as it was given by the LLM. We're not giving the ideal answer, like the golden answer. And that's a huge problem in these internal systems because nobody is willing to sit down and go through the log files and say, oh, that's the answer from the LLM. That would have been the perfect answer. You don't have the golden answers. For the context precision, that's actually okay because you can get at least a somewhat reasonable understanding of the quality of the response by that metric. This is different when you do the context recall, which says, have you picked all the documents you should have picked? Here, you actually do need the documents. You can see that here. You need the IDs of the documents. But how do you know? A random prompt from a log file, how do you know which would have been the perfect ones? And then you can start doing a search again. You can use another LLM to say which are the right ones. And at that point, it feels like this Ouroboros thing, right? I mean, you're using an LLM to evaluate an LLM, which writes an LLM. And in the end, it becomes very difficult. So what is super important in these ones is to talk to your users to see what works. And that's also, if you're using this, use these thumbs up, thumbs down, because that is valuable training information for the people who are writing the systems. Running out of time, so 2 minutes on the last topic, infrastructure as code. So this was all relatively new technology. It was a proof of concept. We didn't want to use ClickOps, so we didn't just want to click around in the web console in GCP. So we used this functionality, show command line. I don't know whether you know it. It's actually super helpful. It does create it pops out, and then it creates a gcloud command that does what you would have done had you clicked the apply button. I had no idea how this technology works at Google. But now I was a bit sensitized, of course, with all the AI and modeling. And then, can anybody see what the problem is with this command? Are we not? Alpha. So gcloud has a feature toggle. And unless you say alpha, you can't use alpha features. And you can say beta, then you get beta features. If you say neither alpha nor beta, you only get the stable features. This is total fabrication. I mean, this is the command to run a Cloud Run instance, which has been around for years. You don't need that alpha thing at all. Interestingly, it worked with alpha, but it also worked without. So no harm done. But again, like you still, even in those things where you think that was probably done by an algorithm, this is probably done by AI at this point. What we later tried is, there's a different technology in Vertex AI called RAG Engine, where you don't have to implement anything. You can just create a corpus, the set of documents, and you can see here actually, down here you see like the chunking size, chunk overlap, and so on. You can just configure the whole thing, or you can just click on import from Slack, take all the data from Slack or from somewhere else, and it will create a RAG implementation for you. We experimented with that as well to see, is that better or worse than what we have? I mean, we wanted to go a bit further. We wanted to use GraphRag and so on, so we thought the homegrown one was actually a better ground for experimentation, but we looked at that. This is relatively new technology. And then, do you notice something? Show command line is missing. So that feature doesn't even exist for the new technologies. So we use this other technology, Cloud Assist. What could possibly go wrong? So this is a chat agent built into GCP. And now I'm asking it, how do I create a corpus with the gcloud command? And the hallucinations are not uncommon with this tool. But what is actually interesting is it has fully adopted the marketing speech. Can you see this? It says, currently creating a RAG engine corpus directly with the G-Cloud command line isn't fully supported. It's not supported at all. And then it says the primary way to interact with the RAG engine API is the REST API, and helpfully suggests to use curl for that. It's not the primary way, it's the only way. So this AI tool really is using the marketing language, and you have to be careful, but it does actually help you. And if you only have a REST API and you want to use shell script, of course, curl is the only answer you can use. In summary, it really felt like this a little bit. This is pre-Gen AI. This is a slide that I took from somewhere, who took it from somewhere else. The idea is you spend a lot of time on ML code, and then you have a little bit of stuff around. In the end, it's actually mostly what's on the right-hand side. There's a tiny bit of ML code in the middle, and everything else just fussing around, getting instances to work, virtual networks to work, API keys distributed, secrets rotated, and so on and so on. That was what our experience was. With that, thank you very much.